Hi, welcome back to my YouTube channel. It's Dr. Gurinderjeet Kaur here. I have covered the basic introduction to machine learning in my previous videos, where we have learned about the introduction to the machine learning domain, what is machine learning, the definitions, why do we need machine learning, and some examples of machine learning in action. So, in this video, we are going to start with the types of machine learning systems. This will help you to break down the different types of machine learning and also will help you to identify which type of ML is best suited for different kinds of problems, like which one will be considered for fraud detection, which category of systems will be considered for recommendation systems. All that will be possible if you have a basic understanding of about the different types of machine learning systems. So let's start with the basic categories. So first category is based on the supervision during training. So based on this category, the ML systems can be categorized further into five different types. We are going to discuss them in detail in the further coming minutes. First of all, I'll be just reading the name of the different subcategories on the basis of supervision during the training of the ML model. So while we are training a ML model on any given data examples, so we have five different kinds of ML models which can be built. First one is supervised learning. The second one is unsupervised learning, then semi supervised, self supervised, and reinforcement learning. We are going to dig deeper into these subcategories now. Let's start from the first one, that is the supervised learning. So, in supervised learning, what do we have? The ML model learns from the labeled data. Labeled data means, let's suppose you have a mail and you know that whether it is a spam mail or not spam mail. So if you train a ML model based on such kind of data where the labels are given to you already, labeled data, that is what I have written here. When a ML model learns from labeled data, that means each input has its correct output. So such category is known as supervised learning. Some common tasks and examples under this can be classified into two things. One is classification, where we categorize into one of the possible categories like spam or not spam, or regression based problems where we can predict the prices of cars, house, any kind of regression where you need to predict a number instead of a category. If you're giving a category in the end, that is known as a classification based problem, and if you're giving a numeric value, then that is known as a regression based problem. Both comes under the supervised learning category. So what is the main idea here? That the data which we have, each input has correct output. That correct output is known as the correct label. Okay, so first thing, we have covered the supervised learning. Now we will be talking about the unsupervised learning. What is unsupervised learning? Unsupervised means the data is unlabeled. As compared to the previous category, the supervised, in supervised, we have the data with every outcome. Like every input data is having a outcome with it, also known as labeled data. But in case of unsupervised learning, the ML models learns from unlabeled data. That means no explicit output is given to you. We don't have that output with us, which we can provide to the ML models for learning. So the ML model needs to find the structure, or we also call some patterns in the input data on its own without any correct output labels. Under unsupervised learning, we have various kinds of problems which are further classified as clustering, dimensionality reduction, anomaly detection, and association rules. All of these will be covered further down in the course, and for the time being, I can just give you an idea. Like clustering is where you can group people into some groups based on their similarity. Like if we are going to divide the visitors of a blog visitors into their interest groups. So that problem domain is known as clustering. We are dividing the people into different groups based on their interest. The second problem category is dimensionality. Let's suppose we have data and we want to visualize that data, visualize very large data into some simplified forms. Like we want to reduce the dimensions of the data. We want to reduce highly dimensional data into simplified data. So visualize data, or we can also say simplify the features. We just want to reduce the number of features, just keep the ones which are actually going to have the information which is required for the ML model to work. Anomaly detection means we want to flag some kind of unusual things. Like in case of credit cards, if we want to flag any kind of unusual activity, then we can use the concept of anomaly detection, apply the concepts of ML, which are used to flag such kind of activities. Association rules is the next category. So it is used to uncover some uh, relations. So we can uncover some kind of product purchase relations, how the customers are purchasing the different products, how they, if they purchase one product, what is the possible chances that they will purchase the other one. So all these comes under unsupervised learning, where we don't have any labels for the input data. All the data is unlabeled. The ML models work by finding some kind of structure or patterns in the data, and clustering, dimensionality reduction, anomaly detection, association rules all comes under the unsupervised learning. I hope I have made all my points clear till this point. So let's talk about semi supervised learning. So, semi supervised learning is something a combination of both, like supervised and unsupervised. Mostly the data is unlabeled, but you have some small amount of labeled examples which can be used to train the ML algorithm. So, the algorithm spreads the labels from known examples to the unknown ones by grouping them based on the similarity. So we have the labels for few of the examples in the data, but we don't have labels for all. So what an ML algorithm is going to do, it is going to apply that knowledge from the ones where we have the known outputs to the ones where we don't have any known outputs based on the similarity. So the simplest example I can give here is the Google Photos tagging. Let's suppose you have given a tag for a person on one of the pictures, but you have not given that tags for all the pictures. But based on that knowledge, information, the ML algorithm will apply the tagging for the rest of the images. So this is one of the simplest examples for semi-supervised learning. Next comes the self-supervised learning. So self-supervised learning is where the system generates the labels from unlabeled data, where the labels, the outcomes are generated automatically, and the model trains itself and uses those labels later on. Let's suppose you have an image of a cat sitting. I don't know how to draw a cat. Like, let's draw it like this. So let's suppose the face is not visible to you. The face is masked, but rest of the body of the cat is visible. So if you need a model which can predict the masked part of an image, the face of the cat, then you are going to apply the self-supervised learning concept. So the use case, as I mentioned, you can restore the image part, restoration. You can delete some unwanted images. So let's suppose I want to keep the person's image, but I want to remove the background. So removing unwanted objects, that is also possible with the concept of self-supervised learning. One of the benefits here of self-supervised learning is that once you have trained the ML model, the model can be adapted. We call this concept as fine-tuning or fine-tuned model, fine-tuning for other some downstream tasks which are similar to that. So classification or in regression, we can use that model which is self-supervised and applied to the other task like classification and regression. So, till now, we have covered supervised learning, unsupervised learning, semi supervised learning, and self supervised. I'm going to talk about the reinforcement learning uh, in the coming minute. So, first of all, what is reinforcement learning? So, reinforcement learning is when a system, we call that system as agent, learns by interacting with the environment, like getting rewards or penalties based on its actions. So we have seen these kind of examples in real world whenever we let's suppose we want to train a dog, we give him or her a treat whenever they follow the instructions. So that is a kind of a reinforcement learning where the dog is the agent and environment is the surroundings where we are training him, giving him the instructions. So what actions using a policy, what actions will be performed, like if the dog is following the instructions, uh, w- what policy instructions we are giving it to the pet, giving rewards or penalties, updating the policy to maximize the long term reward. If we want to maximize that, that training should stay for long, we need to redo those instructions, give the instructions for a couple of days to maximize so that it should stay with that with the pet for a longer time. We have followed this reinforcement learning in some of the games like AlphaGo. So the application areas of reinforcement learning are with the playing bots, where the computer devices plays the game, where a robot learns to walk, or self-driving cars, choosing the safe routes. All these are examples of reinforcement learning, which is also a category of the ML systems based on supervision during training. Here I have shown some steps of reinforcement learning. First of all, the agent is going to observe the environment and decide the action to be performed based on the policy, and once decided, act accordingly. Then based on the action, the pet or the agent, whatever we are talking about, will receive a reward or a penalty. So if the reward is there, it is going to proceed more in that direction, or if the penalty is there, it is going to stop. So based on that, update the policy and repeat so that the overall output is improving over the time. So this is a basic steps of diagram of reinforcement learning concept. So till now we have covered the first category based on supervision during training, supervised learning, unsupervised learning, semi supervised learning, self supervised learning, and reinforcement learning. I do have covered one more thing here, that is transfer learning. So, transfer learning is also very important terminology in machine learning field. I want to make you aware of this terminology here as we are covering all the different types of ML models. So, transfer learning is, let's suppose you have built a model which is performing some kind of specific task, but if you want to reuse this model without training it from the scratch, but just fine tuning it for another related task, then that concept is known as transfer learning, where you're applying the knowledge which is obtained from different data on a different type of data. So, reusing a model trained on one task as the starting point for another related task. This approach saves your time because you need not to train the ML a model from scratch, and data also. You can reuse the previously trained model which have more data as compared to the other one where we have less data. So you can't provide those many examples to train the model. It leverages the knowledge already learned by the ML model. It is common in tasks like NLP, natural language processing, computer vision, where we have some ML models like BERT, ResNet. You will be covering this in the coming lectures if when we reach the computer vision subject. So for the time being, I just want to make you aware that there is a concept known as transfer learning, where we reuse a model which is trained on a data for some another task. Now let's talk about the next category here. I'll scroll up to show you that in under which category we are going to learn batch learning and online learning. So based on the adaptability of a ML model, we can categorize ML systems into two categories. One is batch learning, and the second one is online learning. Let's talk about these two in detail now. So, what is batch versus online learning? Um, okay, let's use a blue color. Batch learning is it will learn from all available data at once. You train the ML model all at once. But what if you have a new data? Then you need to retrain the model. ML model must be retrained whenever a new data is added. It is also called it as offline learning. So it is low adaptable. The adaptability is very low in case of batch learning because you need to retrain the model if you have a new data, which will consume high CPU and memory usage. The ML model will consume the memory, it will also consume the CPU resources. The model will become rot, old. It will be of no use if you're not retraining it with the new data. Okay, it's kind of an off learning concept. But if you compare it with the next subcategory, which is online learning, which learns incrementally, updating as the data arrives. It's like a live kind of scenario. Wherever you have some kind of live new data, the model is improving its knowledge on the go. So it is ideal for real time systems such as recommendation engines. So if you watched a movie today, the Netflix is going to recommend you the similar movies from tomorrow onwards. It's not like we need to train the Netflix model from scratch. So fraud detection also. All these applications where the data is real time, then that concept is known as online learning. It is highly adaptable to the new data, lightweight per step because we need not to train it from scratch. We don't need to train the model again. But if the new data is a bad data, so if we have added a bad data, then we need to monitor that also because these kind of online learning is very sensitive to bad data. We need some kind of online monitoring to save us from those kind of situations. So we have covered the batch versus online learning based on the adaptability of the ML models. We are going to come back and see what is left here. Based on the learning strategy, based on the learning strategy, we classify the ML models into instance based learning and model based learning. Let's cover these two. So let's talk about the instance learning. I have written all the key points here just to save our time. So instance based learning means it memorizes the past examples and compares the new inputs to them. So it's like the example given here is key k nearest neighbors. Let's suppose you have some data points, and I'm going to draw some another data point, and I have a new instance which is somewhere here. So I'm going to see with which data this my new data is more close to. Is this close to this cluster kind of thing or this cluster kind of thing? So I'm going to memorize the past example and compare the new one to the existing ones. So example, I have drawn it for the k nearest neighbors, and I'm going to the one with the closest distance will be having this blue item in its own cluster. So this is known as instance based learning. On the other hand, in model based learning, we generalize the patterns. ML model generalizes the patterns and builds a predictive model. For example, linear regression or neural networks. Are these two are considered under the model based learning. So the, that's all what we need to cover under the basic categories. Let me see if I need to cover any other points. Okay, so let's quickly remember few terms related to all. Supervised learning means learning with answers. Unsupervised learning means learning from patterns. Semi supervised, self supervised reinforcement, all of them are having some kind of hybrid patterns or interactive forms of learning in case of reinforcement. Batch versus online learning. Learning is kind of a static, and online learning is kind of adaptive learning. Instance learning is memory based, where you memorize the past examples, and model based learning is where we are trying to generalize based on the patterns found in the data. So I hope I have made all these terms clear. In the last, I have created a tabular kind of comparison just to keep the things very simple for revision kind of thing. So supervised is labeled data where the answers are known. Applications are spam filter, price prediction in case of cars, houses. Unsupervised, the data is unlabeled. We need to find, the model needs to find the hidden patterns. Application areas are clustering, anomaly detection, dimensionality reduction, and association rules. All those we have discussed. Semi supervised means few labeled data and many unlabeled data. So, label propagation, we apply the labels based on similarity. The example which I have mentioned is face recognition with a few tags, a Google Photos example, Google Photos tagging example. Next is the self supervised, where the data is unlabeled. The labels we need to generate, like predicting the mask information, like some part of the image is missing, we need to generate that. Image completion, NLP, pre training, all these are the application areas of self supervised. NLP is natural language processing. We will be covering this on my channel in the coming months whenever I finish with the ML and few other courses which are on my head. So, reinforcement learning means where we provide some kind of feedback. It can be a reward or a penalty. It's kind of a trial and error based approach. The examples are AlphaGo, robotics, all those comes under reinforcement learning. And lastly, I have compared batch learning and online. Batch learning is trained on the full data set. Once the model is trained, it's kind of an offline training. It's traditional ML based pipelines. But if we talk about real time streaming data, online learning, which in where the models incrementally improve their knowledge on the go, and applications areas are real time kind of fraud detection, all those comes under the online learning. So we have discussed all the categories of ML systems. I hope I have made all my points clear. Further knowledge will be improved when we discuss all this in more detail in the coming lectures. So I hope I have made all the things clear. So I'm going to take leave. Dr. Gurinderjeet here. If you need classes, you can check the description and contact me on LinkedIn. I provide online tutoring services. Thank you very much.